Hello, everyone. I'm Dr. Jet Aguilar. I'm the Vice President of the Astronomical League of the Philippines. And I'm happy to welcome everyone to our first Astronomy Experts Speaker Series webinars. This is the first time that we've done this, and we are very fortunate and happy that we have four eminent and known speakers that will grace our webinars. And our first speaker will be introduced shortly. Before we start the webinar, these are some webinar rules. The question and answer portion will be via the chat box. This will be live streamed. This webinar will be live streamed via Facebook. And now I would like to ask our president, Mr. James Kevin T., to make the welcome remarks.
Hello, everyone. Good evening from the Philippines as well as from the US. It's a good morning. I'd like to welcome everyone to the Astronomical League first Astronomy Expert Speaker Series for this year. This is the first time that the organization is hosting such a big event. And as Jed said, we are fortunate tonight to have a very distinguished speaker, Dr. J. Pasachoff. I have known Pasachoff for a long time. Actually, he's a renowned eclipse chaser, And in 1998, I was fortunate to get to meet him in Malaysia over dinner to talk on the annular solar eclipse. So I like to cut this short. Just want to give a rundown that every April, and this event is the Global Astronomy Month. Per goal is to be one of the world's largest annual event, global annual event for astronomy. So as they said in Global Astronomers Without Borders motto, one people, one sky. So for tonight, we have tonight we have, aside from Dr. J. Pasachoff, I'd like to also invite the other attendees, that we have 3 more events coming up. So if you want to register, kindly register them separately, as tonight's event is separate from the other 3. So you can just cut it out you just register it individually. So like to cut this short, as we are on crunch for time, and I like to tonight we have a special person that I like to welcome, the Honorary Secretary of DOST, Department of Science and Technology, Professor Fortunato de la Peña, who will be giving us a warm opening remarks.
To be invited to this event, and I am very proud that our organizers, which include Imelda and
Edwin?
Yes, are still very active in this area. I still remember them doing this work in the Philippines when they were still, well, many years ago. And I'm very proud that they have continued with this kind of work. You know, the speakers tonight are very respected personalities in the field of astronomy. And we know that during this time in our life, we are experiencing so many changes, and we are trying to find explanations to this. And I believe that astronomy can contribute much, to explain the things that are happening around us. We have taken steps also so that astronomy can can play a more significant role in our science and technology ecosystem here in the Philippines. We supported the establishment of a niche R&D Center for Astronomy, and this is found at the Rizal Technological University, where they are doing R&D, and they're offering graduate courses in astronomy. And of course, even at our Weather Bureau, the Pag-asa, the astronomy work is very much a part, of their activities, and we have people who have been trained in this field or area. Maybe we can also say that we are proud that we have now many contributions to scientific publications in the field of astronomy, and it's really a very, very, shall we say, I really appreciate the fact that there has been collaboration now. Technology has made us closer to each other, and closer to the people who can help us in this particular field or area. Again, allow me to express my pride in having this kind of event, which involve many Filipino scientists and researchers. And I hope that we will continue on with the work and really contribute much to our science and technology field, and of course in generating innovations that can help us. We have so many goals to meet, we have sustainable development goals, and we have to find the right science and technology to help us in this. We have a tagline in the Philippines since I assumed my office as Secretary of the Department. It is science for the people, and I hope everybody will remember that. So again, thank you very much, and again, I'm very proud to be invited here. Salamat po.
Thank you so much, Secretary De La Peña. Thank you for your very nice welcome remarks. Dada?
By the way, for tonight, before Dr. J. Pasachoff start his interesting lecture to us, we would like to invite Imelda Hoson to give him a very formal introduction to the event. Thank you. Mel?
Okay. Well, before introducing our speaker today, I'd like to thank a few people who worked tirelessly to bring this idea into fruition. First and foremost, to my husband, Edwin, to James, Jet, June, Peter, Kendrick, and Ian of the Astronomical League of the Philippines, and to our friends, Jay, Zolt, Joe, and Fred, who wholeheartedly agreed to share their precious time and expertise to the Filipino science community and to the world. To Tarek and Mike of Space.com, who even under tremendous time pressure yesterday, helped in writing a piece about this event. And to the Honorable Secretary of Science for his attendance in this historic step we are taking today in bringing experts in the field, not just to the Filipino people, but to the world. It is now my great pleasure to introduce our dear friend and fellow eclipse chaser, Professor J. Pasachoff, who will share with us the highlights of his eclipse expedition to Antarctica last December. Jay received his doctorate degree in astronomy from Harvard University in Cambridge, Massachusetts, and did his postdoc at the prestigious California Institute of Technology in Pasadena, California. Williams College. He authored 15 books and is a veteran of 74 eclipse expeditions. And his research have been funded by the National Science Foundation, the National Geographic Society, and NASA. Asteroid 5100 has been named Pasachoff by the International Astronomical Union to honor Jay. And Jay, welcome, and I'll give you the floor.
Them decades ago, and I'm honored that they have arranged for me to talk to your astronomical league. Let us see if we can share the screen and go to my talk, and let us hope that this works. Edwin and Imelda, if something is wrong with the projection, why don't you try sending me an email, and I'll have a screen just to monitor extra things here. Anyway, as people know who will be watching this lecture, there is a total eclipse of the sun somewhere in the world about every year and a half, when the moon entirely covers the sun. And my art historian colleague, Roberta Olson, just showed me this diagram from the year 1602. So over 400 years ago, with a very sad looking moon here and an eclipsed sun with some rays there. And the Metropolitan Museum of Art in New York just got this piece, which there's a big whale below that I won't bother going into. So
22 eclipse.
well, okay. And as Imelda said, I've been to quite a number of eclipses over the years since I was a first-year student at Harvard University in 1959. There just happened to be an eclipse that started over Boston way back, and Professor Donald Menzel, the director of the observatory, was a noted eclipse chaser, and he took us up in an airplane to see that eclipse. So in many ways, the eclipse I'm going to talk about today that I observed with my wife, Naomi Pasachoff, and some students and colleagues from an airplane over the Antarctica, Weddell Sea, not yet on this map, is similar in that we were observing out the window of a plane at some high altitude. Now, it is just under 20 years until we have an eclipse that goes right over the Philippines here. So it would be wonderful if I could, at the age of 98, come and observe an eclipse with you on the 20th of April in the year 2042. There are many ways of observing the sun and the Earth, and of course, we have satellites up taking wonderful pictures of the Earth. This is a NASA satellite called Discover to study the climate, and it's way out behind the moon. So this is an actual photograph that that NASA took looking past the moon at the Earth. And if it was the sun rather than the camera taking this picture, that's how we get an eclipse of the sun, because on the Earth looking back, the moon is blocking you, and then exactly what part of the sun it blocks is what varies the kinds of eclipses that we have. And technically, an eclipse is a lunar transit, and that the transit is going in front of the sun as seen from Earth. We can have other things beside the moon that go between the Earth and the sun, and those things are the planet Venus and the planet Mercury. So in recent years, I've gotten interested in transits of Venus, of which we had 2 from the Earth in 2004 and 2012, and transits of Mercury, most recently in 2019. Now, we do have missions that have gone way out to in space to observe the Earth, and of course, as I think we all know, the James Webb Space Telescope is now launched to this point known as Lagrange Point 2, about 1.5 million kilometers away from the sun in a stable orbit, and it is being opened up and seems to be working very well. So we're very pleased with that progress, and we do have various ways of launching things in space, not just NASA or the national organizations of various countries, but now some private organizations, including SpaceX also. So in fact, one of the SpaceX rockets went around the backside of the moon and crashed into it a month or so ago. My colleague Fred Espinac, who will be speaking to you in a few weeks, makes calculations of eclipses with great detail, and here is a map that he has made for us to admire where the eclipses have been in this whole decade. And the first of the eclipses in the decade went by Antarctica on December 4th, and I'm going to talk about that largely today. And we had 3 teams observing that eclipse, and I was in an airplane that left Punta Arenas in Chile, and we flew over here as plotted by my colleague Lynn Schneider to get the sunrise point, which the Union Glacier on the Antarctic continent. Janet Boris and her son Theo, with Christian Lockwood, a student of mine from Williams College, where I've been a professor since 1972, and a colleague, Patricio Rojo, from the University of Chile in Santiago, who went with the official Chilean team taken by the Chilean Air Force, also to Union Glacier. And in fact, the next eclipse of the sun is actually on the 30th of this month, in just about a week. And I am going with my wife to Santiago and to the coast, to Viña del Mar, to see a partial eclipse of the sun. So these eclipses here are total eclipses in purple, when the moon entirely covers the sun, and annular eclipses in red, when the moon is a little too small to entirely cover the sun, even that goes over the sun centrally, and those are colored red. So you see in the United States and Mexico, in the next couple of years, we're going to have first an annular eclipse on October 14th, 2023, and then a total eclipse on April 8th, 2024. I work especially with a meteorologist named Jay Anderson. He and I have a new book out today, this year, the Peterson Field Guide to Weather. And he has for many years compiled cloudy from which we can judge where we might have the best chance of seeing the eclipse. And on April 8th, which we're all excited about in the United States, it is cloudier in New England, which is where I am at Williams College, than it is in Texas. And then it's usually clearer in Mexico and on the Mexican coast in Mazatlan compared to Texas even. So that's where I'm intending to go with my group for the eclipse in 2024. So here is a diagram of one of the eclipses. One of my colleagues has just put together some 2,400 animations of what these eclipses look like, and this is the way it will look in Colorado for just a partial eclipse in 2024. Well, here we are again. That's the same one. Now this camera observed the eclipse from the Epic camera on the Discover mission last June. So that was the first eclipse I had been to in a year, given the COVID travel restrictions, and we observed it from an airplane just over the border in Canada, the other side of the Earth from here. But as you see, it went up to the North Pole. And so I'm amused that in the last year, we had one eclipse in which we can see the shadow of the moon fall on the North Pole of the Earth. And then the eclipse I'm going to talk about mainly today, from December 4th, we could see the shadow over the South Pole. So the Earth is covered with eclipses. Here's where we're going. Oh, this should say, I mistyped. This should say April. So I hope I'm back to sharing here. So on April 30th, we intend to be here, right here, to see a 40% coverage of the sun by the moon. So we have cameras and ready. My mentor, Donald Menzel, who I mentioned, took us to the eclipse in 1959, went to so many meetings that he developed a very doodling habit and did these beautiful drawings. So here's the sun, and here's the eclipse with streamers coming out and plumes coming out of its pole. So I had the great pleasure of learning from him and working with him for many years. And I believe that Imelda and Edwin knew him too. In a nice cartoon from the XKCD cartoonist, here is how cool it sounds to have some astronomical event like a planetary conjunction or even a lunar eclipse or a partial solar eclipse, such as the one I'll see next week, and hear how cool it is to see it in person. And the total solar eclipse is just off the charts. So if some of you there, and many of you there, have not seen a total eclipse, do what you can to see a total eclipse. And if you wait, excuse me, if you wait just under 20 years, there'll be one coming to you crossing the Philippines. I am an astrophysicist, a scientist. So my goals are not just viewing the eclipse, but we have science goals. And in particular, we're studying how the magnetic field of the sun changes over the sunspot cycle. So by observing eclipses for decades, we can follow that magnetic field cycle on the sun. Sometimes we capture an ejection of mass out of the sun. We don't see that at every eclipse, but sometimes we can follow that. And when they come and hit the Earth, they can have big effects on the Earth, and they can zap satellites and do a lot of damage if we're not aware of how to protect our satellites in space. The sun is surrounded by the outer layer that's called the corona, and that turns out to be millions of degrees hot, even hotter than the everyday surface of the sun. So we're studying that by looking at how it ionizes iron gas in the corona. I work with a colleague, especially Aris Voulgaris from Greece, on making those kinds of measurements. And then how does the corona get to be 1,000,000 degrees hot? So we're making some measurements very rapidly, more than 10 times, about 10 times a second, but more often than once a second, to look for vibrations of parts of the sun that could be heating the gas. And then I've been working for some years with Marcos Peñalosa Murillo, unfortunately died a few months ago, but he was an atmospheric physicist for the Earth. And when you take away the sun abruptly from the Earth, it has an effect on the Earth's weather. Clouds can form, waves of density can go out from that location. And we've been studying that, including in cold climates in the Arctic at Svalbard and hot climates in Saudi Arabia. From Svalbard, in the cold climate, here are some images that were taken by my colleague, Aris Voulgaris, and we just had a paper accepted in the scientific journal Solar Physics with the results of the spectra of this 2015 eclipse in Svalbard. And this is a spectrum of the sun. Now, first contact is when the sun and the moon just first kiss, just touch each other. And then the second contact is when the moon moves entirely into the sun. And the third contact is when the moon starts coming out of the sun. So this is what's known as a slitless spectrum. We're seeing the spectrum of the edge of the sun here, and the rest is hidden. And there are different elements that show up at these at this spectrum. And at an eclipse, when the spectrograph was fairly new back in 1868, there was known to be a pair of yellow lines from sodium, the so-called sodium D lines. The optician Fraunhofer in 1814 had first made a spectrograph good enough to follow all these what we call spectral lines. And Janssen went from France to India to study the eclipse, and he was surprised to find out that there were some bright lines in the spectrum, but one of the lines was brighter than the sodium lines, but wasn't right at the same place, and they didn't know what it was. But he realized that it was so bright, maybe he could see it without the eclipse the next day, which he did. And a few months later, Norman Lockyer in England was able to see it, and they didn't know what it was from. So they said, it's only on the sun. So we'll call it helium after Helios, the sun god. So helium was the first element discovered at a solar eclipse. And now, if you look faintly here, you can see a whole ring here in the green. So the next year, there was a whole set of spectral lines that were seen, and they can be graphed out here. So here's a diagram from our new paper, the Total Solar Eclipse of March 20th, 2015, and there are some spectral during the middle of the eclipse. we can see this so-called green line, and nobody knew what that was from. So since the yellow line was called helium, they called this line for a while coronium. But coronium did not turn out to be one of the basic chemical elements, but it took till 1940 to figure out that, in fact, it is from iron that is so hot that it has lost 13 of its normal 26 electrons. So if you heat iron a bit, it loses 1 electron, and then you heat it more, it loses 2, you heat it more, it loses 3. So to lose 13 electrons, it has to be millions of degrees. And so this is the coronal green line, discovered in 1869, and once called coronium, but now we realize it's very hot iron in the atmosphere of the sun. Between the everyday sun and the high corona is a layer called the chromosphere, because it's colorful. Chromos, it's a sphere of color, and I actually did my PhD thesis on looking in details of little spikes, spicules that rise up and fall down every 15 minutes in the chromosphere, and we can get signs of most of the chemical elements in it. We wanted to go back to observing total eclipses, and even in the age of COVID, and Glenn Schneider worked out a path to fly out of the southern point of Chile in South America, and I was fortunate enough to be on that plane. This is a picture that I took out the window just as the totality began. We're seeing here the dark side of the moon that's facing us, surrounded by the solar corona, and here is the shadow coming in, and then beyond the shadow, we're seeing hundreds of kilometers away, where we're seeing light scattered toward us, and the blue part goes to make a blue sky way over there, and the reddish light is coming toward us, similar to what we have for sunset. And then we're just looking down here, and here are my sponsors. I've been fortunate to have sponsorship from the U.S. National Science Foundation, National Geographic Society, NASA, and bring an extra student with the Honorary Scientific Society for Sigma Xi. And I teach at Williams College and have a visiting appointment at the Carnegie Observatories.
Here's an image of
So this is what Glenn calculated. We flew down commercially to Punta Arenas, and then after midnight went out for a 5-hour flight to get the eclipse, and then the eclipse itself, we continued over the Weddell Sea to the point of greatest eclipse, and was visible here in Antarctica. So we flew out for a few hours, and then just for a few minutes to see the eclipse that was about 1 minute and 55 seconds, to look out the window at the eclipse there, and then we flew back. The place where we were in Chile was really due south of New York when we flew first from New York down to Santiago, and then from Santiago continued along the coast. This is now turned here to the point, to the southern point of Chile. There are many reasons why we wanted to be in the air, to get to these access points and to see as far as possible. And we did get some extra seconds of totality for being in the high in the sky. We got the sunspots over the last sunspot cycle, which is about 11 years. So you can see that the number of sunspots, which are daily in yellow, and then they get averaged here in blue and further averaged in red for the overall cycle. You can see this particular cycle, the previous cycle, had a double peak, one hemisphere ahead of the other hemisphere, but somewhere in here is the peak of the sunspot cycle. Any sunspots on the sun, and many days, most days, there were no sunspots on the sun at all. And now in the last year or so, the sunspot cycle has been peaking again, picking up. And you see most days there are sunspots, and somewhere in 2024 or so, we'll have another peak. But whether the peak is a low one like this and there are higher ones before that, we'll have to wait and see. Different people have different predictions, so we do the best we can in studying those things. I had with me a couple of students from Williams College, Anna Tossolini and Peter Knowlton, and one of our alumni, Mujo Lu, now works as a flight engineer for SpaceX. And and we were finally able, late at night, at midnight, to board LATAM Airlines, that's the Chilean National Airlines plane, to fly down to Punta Arenas. And here I am with my traditional orange pants that I wear on eclipse days. So we've just taken them out for me to take to Chile next week to wear at the eclipse next week. Here's my wife, Naomi Pasachoff, in the airport with Mujo, and here's our student group, David Slisky and his fiancee Nicole, and Emma, is a high school student who was with us for the eclipse, Emma Sobel. Here we are on the tarmac again, boarding at Punta Arenas to fly out over the ocean near Antarctica to get to the eclipse. We had to delay a little bit to be in the right time. We often get the chief pilot of an airline because it's an exciting thing to do and takes a special skill to get the timing exactly right to be in the right place at the right time. In fact, there was an emergency 2 weeks before the eclipse. We were supposed to be in Airbus 321, but there are various safety rules, of course, for the big commercial airliners. And if something goes wrong with an engine, you have to have a place to land in an emergency, and that was to be the Falkland Islands. But given the COVID, the Falklands didn't want to take the possibility of having to quarantine 30 or 40 people. They couldn't handle it. So we couldn't use the Airbus 321, and the travel agent, Tim Todd, I was glad to say, arranged from LATAM to get a Boeing 787, a much bigger plane with more engine capacity, that even if an engine went out, it was in a safe mode. And so here is our Airbus, not our Airbus, our Boeing 787 Dreamliner, and there were actually enough people for a second plane. And here I am with the pilot and with Tim, and so we took off, and there started to be the light before sunrise. And here's David with one of the telephotos. Here Emma with another telephoto out the windows there. David Foote and Joyce Feinberg decided not to come, given the arduous getting through the various COVID protocols, and they gave their place up to education coordinator for the International Astronomical Union, who took two PhD candidates at the universities in Valparaiso and the University of Chile. And here's a view at the window. And just when the first the valley on the edge of the moon allows sunlight, bright sunlight, to come through, whereas the moon is blocking out the rest of the everyday sun, we have what's called the diamond ring effect. And here is an image that that they took from the airplane with the diamond ring effect. So here is the same image you saw from me, just with my iPhone pointing out from an altitude of 41,000 feet on the Boeing 787. And here is our team.
The observation.
Now, I've mentioned the magnetic field of the sun and how that varies over an 11-year cycle. But there are details of the magnetic field. The sunspots in particular are regions of very strong magnetic field, thousands of times the average magnetic field of the sun. And a group headed by John Linker at a company called Predictive Science Incorporated in San Diego, California, uses observations of the sunspots and other measurements of the magnetic field to predict what the corona will be like at higher levels, because the measurements they're making are right on the surface of the sun. The everyday surface of the sun is called the photosphere, because photos is where the light is coming from. So they're trying to make the predictions to extend it. So here is, so they use those data over the month in advance to predict where the coronal streamers will be. And so here is a prediction that they various ways what the streamers are going to look like on the basis of the magnetic field. And then here on the right side are measurements that my team made from Antarctica and from the plane. We worked with the musician Wendy Carlos in New York, who's a skilled computer image processor. And within a few days after the eclipse, we were able to compare in a NASA press release the images that we actually got at the eclipse and their predictions. So here is just a little more of that, a little enlarged here, and the constant flow shapes, the dynamic space conditions known as space weather. So you can see a daily sunspot picture at on the web, for example, at spaceweather.com. And so modeling the corona is a key part of better understanding and eventually predicting space weather, which affects satellites, astronauts, and everyday technology like radio and GPS, which are often broadcast down to us from the satellites in orbit. So, so here are images that we have in that release, and you can get the release online, and there's a slider that allows you to show the whole image of the predictions from Predictive Science, and you can slide it the other way and you can see our whole observations of composite images. Now the sun, the corona, is 1,000 times brighter here than here, so no one image gives you the full corona. And so this is a collection of several different images put together by Wendy Carlos to show the streamers. But you can see, for example, this beautiful streamer that's coming out here. And then there tend to be these plumes at the poles, which you even saw in Professor Menzel's doodling. So a few days before the eclipse, Predictive Science Incorporated put out a final prediction, and they predicted various details of the spectra, in addition to just the shape. So here is their prediction here, and you can see at this stage of the sunspot cycle, which we're not quite at maximum, but we're coming up from minimum. The corona is extended to the equator on either side, and then there can be some plumes like a bar magnet and iron filings that don't show too well in this particular rendition here at the North Pole or the South Pole, but we can certainly see the equatorial extent of the streamers, and the various ways you can calculate the brightness or the density of the gas in the streamers. Also, right at the chromosphere, there are some gas of the same temperature as the chromosphere, have part way between the photosphere and much less than the corona, only around 10,000 kelvins, 10,000 degrees. We have what are called prominences, which stick up, and a little stronger magnetic field is holding them up in place. So here was their posting. You see, so on November 13th, they posted already, and then their final posting was November 21st, a couple of weeks before the December 4th. But they're using magnetic field images from the sun, and the sun, of course, is rotating. We're only seeing one side. So some of the images around the backside are already 2 weeks out of date, but they do the best they can to predict the shape there. And there are various scientific mathematical techniques such as wavelets to bring out the details in the images, and to see the details in the streamers that come out, especially at equatorial latitudes during that we can see during a total eclipse. The magnetic field from the sun goes way out into space, out even to Jupiter. And here's a view of their posting, which shows, for example, a big magnetic region there there would have been sunspots there, and some sunspots in here, sunspots here, and the low level magnetic field, low height magnetic field, but then an overall magnetic field of the sun that goes way out into space. So this was their final prediction from the 27th of November. So that's about a week before the eclipse. Anyway, here is an image that we got from the airplane, and that was put together from several different images, and we can see streamers here, and you can emphasize, these are compound images, so we can emphasize the contrast to a different degree. And here again is the slider here, but now I'm emphasizing our images here and the base of these streamers that we observed. So I work especially with Vojto Rushin from the Slovakian Academy of Sciences, and we also have a new paper on the view of the streamers, but what we're up to are the detailed studies of the last American eclipse in 2017. And so that paper came out recently in the scientific journal Solar Physics. So here is that wide field view of the dark side of the moon facing us, and the solar corona, and the shadow here, and viewing way outside the umbra. The umbra is the shadow of the moon as it falls on on the Earth. We could look out the window, in fact, and look down, and Michael Halper took some images and could see the second plane that was flying a couple of thousand feet, 1,000 meters or so below us. And so we just codenamed plane blue for them, code gold for us. Here is the setup of Aris Vulgaris, looking out some windows with these two spectrographs. The 787 was unfortunately not as good for us as the Airbus would have been, because the Airbus had ordinary windows, smaller, but still made out of ordinary plastic, whereas in the 787, the Dreamliner, to allow it to be dimmed without using window shades, and those chemicals blur. We had a visiting University of Chicago scientist, Tom Economou, who worked with him, and so they were a few rows behind us on the plane. And I mentioned the green line that has lost 13 of its electrons. So iron 1 is neutral, so iron 2 is once ionized. So the number of the electrons lost is 1 from the Roman numeral. There was a red line, not quite as ionized, but just under 1 million degrees. And then here is the line of helium. And in these, there's the images are including both the left side and the right side of the image, which is why these are doubled. And the strongest normal line from the atmosphere of the sun is the first of what's called the Balmer series, H alpha here. So here is a scan of these lines, of these spectra. And just to take an image in the coronal green line, Aris put this together. So here's the orientation of the sun, the North Pole and the South Pole, and there are active regions. The surface of the sun. So here's this same image here with the 3 active regions showing there. Andreas Müller is an amateur astronomer from Germany who takes excellent images, and he got this image of the diamond ring effect, just beginning here from his location in Antarctica, and he is now taking over the duties of listing for dozens and dozens of eclipse observers what eclipses they've seen and their durations in the listing of those who've been observing eclipses. And so here a little further, when some more let some sunlight through, and the sunlight is thousands and thousands of times brighter than the solar corona. So it really makes an effect in the camera. And here again, with looking like wings with Andreas's views. Now, working with my former student and now colleague, professional colleague, Dan Seaton, who works at Southwest Research Institute in Boulder, Colorado. He has put together for us this composite, and there there are spacecraft up now that have what are called coronagraphs that make an artificial eclipse, but we are not yet able to make artificial eclipses as good as the real eclipses because the sun is so bright that even the inner corona is so bright, they have to hide the inner corona. So here we would normally have the black moon, but we've pasted on instead of black just to show you where the active regions are. This is one of the images from a spacecraft with the one that made those magnetic field measurements. And then that's surrounded in this donut that is otherwise uncovered from spacecraft. We've put in our eclipse image, our composite eclipse image. And then there's a coronagraph view that shows streamers going way out. You can see their equatorial streamers. You can see how the streamers that we've observed close in continue, of course, as they must, but this is a simple image. Here's a streamer at this high latitude that continues out into space. And Andreas has worked with a computer scientist, Miloslav Druckmuller, in Germany to do this very detailed processing from a number of different images. And you can see the North Pole, you can see the polar plumes over here. These are Andreas's and Miloslav's images. These are not my images, but I'm very glad to see them. So we can see these polar plumes here, and we can see big configurations on the edge of the sun. We can see the streamers going out into space. So here is the image that you saw there, and some details here. A composite image from the team at Union Glacier, especially with Theo Boris, Christian Lockwood, David Zimmerman, and my students, Peter Knowlton, Anna Tassolini, Emma Sobel, alumni Mujo Lu, Aris Vogaris, and then David Slisky, his fiancée, Nicole Mazzetti, who was working with us, and my wife, Naomi, and support from Williams College and the Atmospheric and Geospace Sciences Division of the National Science Foundation. It's interesting to me and to some people that at the NSF, the eclipse work and the solar work is not in the astronomy division, but it's in the geospace sciences, with the atmospheric and geospace sciences division, which are maybe rival divisions out of the National Science Foundation, and now applied to them recently for renewal of the grant for the next eclipses here. So here is the outer image from what's called the C2 coronagraph on the Solar and Heliospheric Observatory, which is launched by the European Space Agency. The coronagraph was made from the US Naval Research Laboratory. So there's a big composite from different organizations to study the sun. So here is this image again on December 4th, 2021 here. Now, there are some different instruments that can observe the surface of the sun, and Dan Seaton went out to Boulder from Belgium, where they had and have an instrument for looking at the surface of the sun at some extreme ultraviolet wavelength, far shorter wavelength, far shorter color than we can see with our eyes, solar ultraviolet imager. And so this pastes that image there. And again, we can link these images that show especially the hot gas, the magnetic field, with the images we get from space. And you can see this big eruption that was going on during the eclipse. when it's going off to the side like that, we're safe on Earth. But every once in a while, there's a halo eruption, which looks more or less equal around, and then it's coming at us. And then we might get a day to make precautions and turn off high voltage on some of the satellites, for example, and take other security measures. So here's another one of those composite images, unlabeled. Pleased with these images that we got on December 4th. Horolek was on our plane and with a wider view camera than I had, and so he could look back and see the engines and see the whole umbra here, and you can see the second plane here below us in this remarkable view. And this was posted on Astronomy Picture of the day, day after the eclipse. So here's the path as it was again. Remember, we flew out of Punta Arenas, and we got here to get the eclipse near sunrise. And so that's where our images came from. The details are in the lower left. And then the eclipse proceeded over Antarctica. While we were in Punta Arenas, we were in a hotel and with some meetings. Here's my wife Naomi, David Slitzky, some of the others getting a briefing, and then perhaps you know about pinhole cameras, just looking through some holes. Ordinarily, you what the sunlight is, but when the sunlight is partially eclipsed, and so here's such a picture, and then here again is another image looking down at the second plane, and here the captains are pleased with the results. Valdea got his own images of the umbra. Here that shows here, but here's our plane. So Catalan was looking up, and here's our plane in the sky, remarkably at 41,000 feet, as we observed the eclipse there. Now, I mentioned that we had some teams on the ice, and here is the group sponsored by Janet Boris and her son Theo, and her husband Peter, and then Christian Lockwood, who just graduated from Williams College with another visitor, David Zimmerman, who works with our colleague Ron Dantowitz. So here they are out on the ice, and look at the beautiful weather they had there. And this is just an enlarged view of that. So they were on Union Glacier. They had this equipment that was put together, especially by Ron Dantowitz. And they were there for 2 weeks, long enough to qualify for the National Science Foundation Antarctic Medal. The sunlight, of course, dips as the moon covers the sun, and then it affects the temperature and pressure. We had measuring devices there, so it went from a low 15 degrees Celsius or so from the eclipse. So here is an image that we've posted on Astronomy Picture of the day. here on December 9th. So that's 5 days after the eclipse. You can get that, and maybe I recommend you, in fact, look at Astronomy Picture of the Day every day. It's at the URL of apod.nasa.gov, and there's a new interesting picture every day. So this one, they credited Theo and Christian and David as part of my Antarctic expedition and compositing by these colleagues. Another APOD, this is somebody not connected to us, but just from the actual South Pole, took images all around here, including the eclipse itself, the totality itself, and from the actual South Pole here the view, which was not in totality, but here are the views of the partial eclipse. And then our colleague Patricio Rojo from the University of Chile put together 33 images with his Sony camera, and we've composited that for him, and we're still going to study that. And Roman Panur is a computer scientist who worked with Rushin and me. So again, we're going to meet Pato next week for observing the April 30th partial solar eclipse. But here's the beautiful stuff that he got and that Roman and Voito brought out from his imaging. So we're certainly very pleased with what we saw. From an American spacecraft, the geocentric spacecraft, you can see this repeating loop of the actual eclipse. Look at the eclipse coming across here, the shadow of the moon coming across Antarctica. And this is the image that you saw at the beginning, where that image went across the South Pole. And here is the path there of totality coming across Antarctica. One of the astronauts was in the International Space Station, and she pointed her camera out the window and saw that shadow that you just saw from the GOES spacecraft. So if you're up in space, you can just see the eruptions. There's a solar orbiter. That is a spacecraft the Europeans are sending out, and people are working on improving the observations from space. And so there are these big eruptions that come out, and you want to be safe from those. But we capture them at one moment at the total eclipses. And just to finish up, once we got back to Punta Arenas, we wanted to see some penguins. My sister had made this paper mache penguin as a little girl, and but we were able to go out the next day and just so I think that is what we want to. It's just a cartoon. What I want to say about the eclipse. We're very pleased to be there, and we're very pleased to get such good observations. And I thank you for inviting me to talk about them. So back to you, Edwin and Imelda and others.
Thank you so much, Dr. Pasachoff, for that very clear and comprehensive exposition on the scientific value of solar eclipse observation. As amateur eclipse chasers are most of the time just for the taking beautiful pictures of solar eclipses, and now we appreciate more the value and the scientific contributions that have been made possible with the solar eclipse observations. And I am looking forward to observing the 2042 total solar eclipse here in the Philippines. I will just be 80 years old at that time. So looking forward to observing it with you, Dr. Pasachoff, and maybe with Imelda and James as well. We have time for some questions from the chat box, and with your, I will start reading some of them, Jay, and ask you to answer some of these questions. Yeah. So the first question is, scientists have been studying total solar eclipses for more than a century. What have we learned about the sun through solar eclipses for the benefit of our amateur audience, amateur astronomers?
Well, we've certainly learned about the levels of the solar atmosphere. We've learned about how energy is put into the outer layers of the sun. We've learned how the configurations and the eruptions from the sun can affect the Earth and affect the satellites. Once the power grid in Quebec and Canada was down for some hours from a solar eruption, we don't want an even bigger eruption to go off on the sun. So we're learning how to monitor the sun and see what's going on, and how to use the observations of the magnetic field to predict what the outer layers of the sun will be and what eruptions there may be.
Thank you so much, Jay. The next question is about your passion for solar eclipse observation. So far, you have observed 74 solar eclipses from all over the world, totals, annulars, hybrids, and partials. Why are you so passionate in trying to see as many solar eclipses as possible?
Oh, because they're just so wonderful. I think everybody should be this passionate. I invite you all to come with us for all these eclipses.
Yeah, we know the feeling. So we're looking forward. Actually, we're also excited about the Great American Total Solar Eclipse of 2024. And hopefully we can be with you there, sir. The next question is, what were the technical challenges observing and imaging a solar eclipse in very cold temperatures? How about the elevation of the sun above the horizon?
Yes, the sun is low. In fact, the eclipse that I'm going to see next week is goes down to sunset, so it's the hour and a half before sunset. So we're going to so I've rented hotel rooms with a balcony that face west, that face the ocean to see that hour and a half. But we do what we can to observe in the best conditions we can. At the very beginning of my talk, I showed you an image from the 2019 eclipse that was taken by Aras Vulgaris from the top of the Cerro Tololo Observatory, which is at a reasonably high altitude in Chile, but rarely does an eclipse cross a major observatory. And when that happens, they don't usually like us to use the big telescopes because they're afraid that that will blow out all their cameras and their telescopes with the bright sunlight. So there is a special new observatory being put up now called the Daniel K. Inouye Solar Telescope in Hawaii, and there the solar energy is concentrated in a way that they can have a water bath to cool things down and just let a little bit of the solar light come through in a level that can be handled. So there are a lot of special techniques that you actually need to observe something as bright as the sun.
Thank you, Jay. The next question is in relation to taking solar eclipse photos while in an airplane. No? As the plane is traveling at high speed, how do you compensate for the movement of the plane to get sharp images? And I am amazed that you're just using the iPhone for your imaging.
Well, that was just my snapshot out the window, but as you saw, there was some big telephotos there too. No, we're just dependent on the pilot flying straight.
Thank you. Another question, are there things that cannot be done from the plane and that need to be done on the ground?
Well,
Yeah.
from a high altitude, you could see more infrared. That doesn't come through the Earth's atmosphere, but there are big advantages in having a sturdy base on the bottom too. But there are some inertial guidance platforms that you can take on an airplane. So there are all kinds of levels of complication that you can use to try to steady your images. But we did suffer from the quality of the window of the 787, that we had to go through the windows. So we would rather be on the ground with a straightforward view and a regular tracking mount and stability.
Thank you. Another question in relation to plane solar eclipse observation. How do the pilots fly towards the eclipse? Do they have to wear special gear?
No,
glasses?
they're not staring. They're not staring at the sun. There are no special rays. You just don't look straight at the sun, just the way you won't look straight at the sun today.
Yeah. So they just use the instruments, right?
Well, yeah, you just fly straight ahead,
Yeah.
but you can look all around.
Okay. And there's another question here from Denzel Alien Mallorca. In your entire life or career for many decades, what is in particular the most beautiful or memorable solar eclipse that you have witnessed?
Always the next one.
Great answer, sir. I think there are no more questions, but if you allow me, I read some in one article before that in the solar eclipse observation in Antarctica, this could be related to the Earth's magnetic field. Is there any relationship with the changes, for example, in the atmospheric? Is that ionization and the Earth's magnetic field that can be affected by it? Yeah.
Yes, so there are effects on the Earth's ionosphere, and we have arranged a session at what's called TESS, the Triennial Earth-Sun Summit, which will be in August. Every 3 years, we have such a thing between the American Astronomical Society and the American Geophysical Union, where people come from all over the world to discuss the effects, many things about the Earth, but the part that has to do with eclipses, we do have a talk on measurements and the changes in the Earth's ionosphere when the eclipse takes the sunlight away.
Thank you so much again, sir, for graciously answering all the questions here. Are there any more questions? There are no more questions in the chat box, but do we have questions from our panelists?
Jet,
Yeah.
I do have a questions for us. One question for Jay. You alluded to going to Mexico or Texas for the upcoming eclipse in 2024. So which is your choice for the observing site?
I go by the predictions, the statistics online from the meteorologist Jay Anderson. He has a website at Eclipsophile, ECLIPSOPHILE. So it's eclipse without the E, O, file. And that shows that it's clearest on the Pacific coast, where the eclipse first hits Mexico. So we're planning to go there. The city of Mazatlan is a city with many hotels on the Pacific coast of Mexico. So anyway, Edwin, Imelda, I look forward to seeing you stateside. And I do thank you for arranging this and for inviting me to participate.
Yes, and we look forward to seeing you next year for the annular eclipse. I'm sure you'll be there.
Yes, certainly. Okay.
Thanks, Jay.
Oh,
Bye.
Before we let you go, Jay,
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 Yeah, so very nice.
yeah, we'd like to express our gratitude by awarding this virtual certificate of appreciation. May I ask our president, Mr. James Kevin
So much.
Yeah.
It'd be very pleased.
James.
Jet, can we have a group picture before?
Yeah, I will read. I will read the certificate of appreciation first.
Okay.
So this is presented to Dr. J. Pasachoff for his invaluable insights, experiences, and expertise shared with the participants of the webinar entitled An Antarctic Eclipse, held during the 2022 Global Astronomy Month, given this 23rd of April, 2022, signed by Mr. James Kevin T. and Dr. Jose Francisco Aguilar. So before you go, Jay, I will taken enough of your time. Can we have a group picture with everyone? Turn on your videos, please. There. Okay. Who will take the picture?
Casey?
Casey, please.
I'll do it.
Yeah.
All right. 3, 2, 1, smile. All right, hold on. I'll take another one. Wait. Okay. 3, 2, 1, smile. All right. Thank you.
The Honorable
Thank
Secretary
you.
is not here anymore. Dr. De La Peña is not here.
Yeah, I think he signed off.
Yeah, okay.
Yeah.
We'll thank him also.
Anyway, thank you. Thank you very much
Thank you.
for inviting.
Thank
Thank
you.
you, Jay.
Thank
Thank
you
you
very much.
for
Thank
you.
accepting our invitation.
Goodbye. Thank you.
Thank
Bye.
you. Bye.
Thank
Thanks,
you.
thanks,
Thank
Jay.
you. Bye-bye.
Thanks, everyone.
Thank you.
Take
Thank
care.
you.
Now let me just before we go, I would just like to thank our audience for participating in this webinar. We'll also be given a certificate of attendance via email. And before we end, I would like to announce our succeeding webinar. This will be on April 30, 2022 at 8:30 p.m. Philippine Standard Time with Zolt Levi giving his talk on visualizing Hubble's colorful universe. So that will be, again, a very, very interesting talk. And on May 7, we will have the talk by Joe Rao on the Night of the Shooting Stars, again on May 7 at 8:30 p.m. Philippine Standard Time. And our last but not the least speaker for our webinar series is Mr. Fred Espinac, or Mr. Eclipse himself, who will talk about predicting and chasing solar eclipses on May 29, 2022. That's a Sunday at 10 o'clock a.m. Philippine Standard Time. Registration is free, so please register and attend. Thank you very much. That ends our webinar. Thank you.
Thank you.
Bye-bye.
Bye.
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 Thank
See you
you.
again next week. Bye.